All right, guys, welcome, and we're gonna get started right into it. Today we are just discussing the second part of our differentiation rules. When we started in our previous lesson, we just looked at basic rules, playing around with sets and all that. So what we're gonna do today in principle is we're gonna look at more complex expressions where brackets are involved and you have more than one term in the denominator. And this is where factorization, I must say, will come in as well. So you do need to recall those basic concepts such as factorization, and that could be the cubes, that could be highest common factor, difference of two squares, could have a trinomial. So it's just one thing to take note of as we get into this section. So let's start right away with a recap. Remember, a few things that we said in our previous meeting is that if I've got a situation where I'm given an expression or a function f of x, 1 over 4x squared, okay, then this one is already in standard form. In other words, the variable, the independent variable x, or the variable in which the function is defined, is already in the numerator. So I can just differentiate this easily. So 2 times 1 over 4 is a half. So I'll get a half x. All right. But then we spoke about other instances. If I have 1 over x cubed, for example, I need to rewrite this first as x to the negative 3. Now, because this is given as y is equal to something, I will have to find my first derivative using the notation dy dx. So then this will be negative 3x. Because I'm subtracting 1, then I'll have x to the minus 4. We also spoke about square roots and cube roots. So if I've got in brackets to find the derivative of, let's say, 2 times the cube root of x, then it is important to note first that I need to express this differently without the square root and write it as 2 times x to the 1 over 3. Remember, there is that invisible 1. So once I have this now, I can differentiate. 1 over 3 times a 2 will basically become 2 over 3. Then I'll have x, and then I'm going to go 1 over 3 minus 1, which I think will be a negative 2 over 3. Now, what is important, especially when it comes to notations like these, it is important to note when to stop writing d dx. Okay, and I hope you do notice I stop writing d dx when the moment I apply my rule, the rule for differentiating. Okay, so it is very, very important. Students often lose marks because they don't know exactly when to stop writing d dx. And as I said, math is a language, and you will be penalized if you do not notate things correctly, just as you get penalized for that incorrect spelling or grammar. The same thing happens in mathematics. So today we're going to look at complicated expressions. So what makes them complex is just that there's a whole lot of things going around on complex expressions. And after today, then you should be able to complete those questions in the paper one booklet on differentiation, all questions now. So you should be able to do beyond first principles, okay? So let's give you the tools. So first of all, for my first complex expression, I've got y is equal to x minus 2 into x squared plus 2. Now, before I differentiate, I need to make sure that I've got each sort of x term independent, all right? I do not have a product. So if I've got a product and I've got to differentiate, I need to sort this out. Of course, when you get to university next year, or for those who do further studies, you learn about other rules of differentiation, things like the chain rule, the product rule, quotient rule, etc. but we try and keep it basic here in grade 12 normal mathematics. So obviously you're going to FOIL here, and this will become x cubed, and then I'll have a 2x, and then I'll have a minus 2x squared and a negative 4. Then the next thing, now that I have y and each x term is independent, then I can finally find dy dx. Again, it is very important to note at what point do I write dy dx when I apply the rule. So here dy dx will be 3x squared plus a 2 minus 4x. And remember, the derivative of a constant is 0. So in each case, what have I done? I have multiplied the exponent by the coefficient, and I have subtracted 1 from the exponent. So it is important to note that with the 2x, the x term goes away because 1 minus 1 is a 0, and anything to the 0 is a 1. The constant, we already know there was sort of an x to the naught, so 0 times negative 4 is a 0, and whatever is left here, an x to the minus 1, that x to the minus 1 times 0 will give you a 0. That is why it disappears. So please take note of these few things. All right. Before I go any further, I want to actually check that I am on the same wavelength as you. So please, if you will, won't you please find the derivative of the following? I've got x plus 1 over x into x minus 1 over x. Okay, but today I will really try and take this step by step because it is important that I do not lose you. We're gonna do different types of complex expressions. So before I move on, I must make sure that you got this one. So please try this one. So let's look at the solution. First thing to take note of is you're gonna keep the dx. You're not gonna get rid of this, and you're gonna do the foiling. Now, if you notice, you've got a special product here known as the difference of two squares. So what will happen is as you FOIL, you've got to end up with an x squared minus 1 over x squared. That's what you got to end up with. And if you go in the long way, what would have happened is, I want to write it down here and show you what should have happened if you went the long way. You'll see we still get to the same conclusion. So watch, you multiplying the x and the x, you get an x squared, right? Now, what catches a lot of students, and you need to be aware of so that you don't fall for this, is when you multiply x by 1 over x, what actually happens is that you end up with a 1 because really this becomes an x over x. So you're basically having a minus 1, and you do this here, you get a plus 1. And then another issue is this one. 1 over x times 1 over x. We often see students writing x squared here and that kind of thing. So when you multiply fractions, just remember your basics. You multiply numerator by numerator and denominator by denominator. So that is why then you would have had a minus 1 over x squared here. So that is a 0. It goes away. Okay, so you should be able to pick these little things up here. All right, so now I'm still writing dx because I do notice I've got a little problem here. The x squared is in the denominator, so I've got to fix that. Then I get this, right? Now, I'm going to apply the rule, and because I'm applying the rule, I stop writing dx. So this is 2x. Watch out there. You are multiplying a negative 2 by a negative 1 here. So this must become a positive 2x. And guess what? You have the negative 3 here. And that becomes your final answer. You got this, well done. You didn't get this, it's okay. It's a learning curve. And that's why I've taken time to explain actually what happens when you multiply out those two brackets. Okay, another one that I would like to do, let me do one that has a square root in it. So here we are told g of x is equal to, and I'm given the square root of x plus 1 over the square root of x. Check this out. It is all squared. Again, I don't know how to say this, but one of the popular errors is seeing students distribute that 2 there. Now, this is an error that is acceptable at grade 9 level, but we can't accept that in matric. Sometimes it is seen as a breakdown, meaning you just get a 0 throughout, all right? So please be mindful of the fact that what you are doing here, you cannot distribute an exponent over a positive or a negative sign. So what you need to do, if you don't see it, there's a quicker way to do this, of course, but what you should do for yourself as a huge favor so that you don't lose out on these easy marks is to rewrite this thing like that. Why? Well, simply because x squared means x times x, or you get x squared as a result of multiplying the same thing by itself. So take note, that is the principle I'm trying to share with you here, that x squared means you have multiplied the same thing by itself. And so if I've got a square root of x plus 1 over square root of x all squared, it means I should rewrite this thing twice because it's the same thing again. I've multiplied it by itself twice, okay? So that's very important to note. Then again, what we're gonna do, we're gonna FOIL out, right? And now let me show you something interesting again. Whenever you multiply the square root of the same number, okay, by itself, then you're gonna get x. And this has to be true because square root x means x to the half. So you have x to the half times x to the half. And this would mean you adding the halves according to law 1 of exponents. So this ends up being x to the 1, but we don't write that 1, it's invisible. So that's why square root of x times square root of x is x, okay? So that's what happens when you do your inners, your firsts, well, applying FOIL. Then I hope you've seen this one already. When you multiply the square root of x times 1 over the square root of x, the result is a 1. So I'm just going to be quick here and write 2 in there because I know there's going to be 2 of those. And finally, I'm going to have 1 over x. But then I do notice I've got a problem there with the 1 over x. So I'll write this as x to the negative 1. So this is what g of x is if I want to be able to differentiate it. Then finally, we can find the derivative, and the result will be 1 plus a 0 minus x to the negative 2. So that will become the result. So please be very cautious and careful when dealing with this. All right, as I said, today I'll do an example and give you something to try. So please, won't you try and do this? D dx, you're finding the derivative of the following negative 2x into x minus 1 all squared. Please try this. If you can finish it within 2-3 minutes, that's a good work rate for a start. All right, we should be done. So what you're gonna do here, you're gonna keep writing the ddx. You're not gonna get rid of that. And I've chosen this one again deliberately because another temptation here is to distribute, but then you can't distribute when you still have to deal with the exponent. You cannot, all right? So this is where people start talking about BODMAS instead of BODMAS. Okay, look at what is inside the brackets. Can you simplify it any further? No. All right, now look at the exponents. That's what should take the next priority. So, excuse me. So you gotta do this, then I'm gonna quickly FOIL there. So that's x squared minus 2x plus 1. Now, finally, I can distribute. So this becomes a negative 2x cubed plus, don't forget signs, numbers, and letters. Then that's 4x squared, and this is minus 2x. Now watch this. When we find the derivative now, or when we finally apply the rule, I stop what? Writing d dx. So I get straight into it. This will be negative 6x squared plus 8x minus a 2. And that's the final solution. Okay, you have differentiated. Well done. If you've got this, as I guess we would, just for the time being, help with that. Yeah, maybe let me just award every effort that has been put here. Okay, so all of these, what we've done so far, we've been addressing really brackets. Okay, we started off very easy and say FOIL when you need to. We said there could be patterns that arise, difference of two squares, could be rationals that arise as well there, or irrationals that arise. So be aware when doing these things. Now, we're gonna see how factorization comes back in metric. You thought learning the quadratic formula was it? Now I've got some bad news for you. You still need to be able to factorize. So let's take, I'm going to call this one P of X. Oh no, red color is a bad idea here. I'm going to call this one P of X equal to, let's say 2x cubed minus x over 2x squared. That's what P of X is. And obviously, I mean, the standard question is find the first derivative or differentiate P of X with respect to X. Now, the fraction is obviously a problem here. We have seen this already actually in the previous examples, that we always got to start by dealing with the fraction. So in this instance, I want you to note that we're going to apply one of the most basic and simple rules that you learned when you were adding fractions in primary school, even in grade 8, 9, and there. Watch. So if I've got a fraction 2 over 3, and I want to subtract, let's say, a 1 over 3, what do you often do? You go, well, since the denominators are the same, then I can simply perform the subtraction on the numerator. That's what you do, right? So you know very well the left to right process. What you need to see here is that to quickly deal with the fraction here, we need to reverse this process and now work from right to left. We need to work from right to left. So we need to, in other words, see that this actually can be written as 2x cubed over 2x squared minus x over 2x squared. It's the same thing. It's the same thing that is happening there, not any different. And now, guess what? You can deal with this, right? 2 divides 2, x cubed divided by x squared is an x. All right? Again, there, x goes once into x squared, you'll be left with an x. So actually, this becomes 1 over 2x. But we know we've got a problem to resolve here. So this becomes x minus, watch now, 1 over 2 times x to the negative 1. The 2 is just a number. We don't have to bother it in this instance. So finally, I'm going to find the derivative. Watch this. It's a 1. A negative 1 times a negative half becomes a positive half. Then this becomes x to the negative 2. Of course, this is not the only way. You could have seen a highest common factor there of an x, but guess what? You're still going to remain with the same problem. So this is actually a better way to go around this, okay? So beware of that. Now, another instance, though, is that you may have more than one term. So I want to put a contrast here so that you know when to apply this grade 8 strategy and when not to apply it. And this is a situation now, I'm giving you an example when you should not, do not try it in this instance. What instance is this? Suppose I've got, let's call this one K. I've got an expression which I call K, and it is given as follows. It is given as x squared minus 1 over x plus 1. So you see now, you have two terms in the denominator, and that's what prevents you to do this. In fact, if you were to apply that rule, you only have one option to rewrite this thing as that. And that does not benefit you, at least not now, because you have not really done advanced calculus well. You have not done integration and those other things. So it doesn't really differ. It doesn't benefit you. So what you're going to do here is you're going to use factorization. You need to note that the numerator is the difference of two squares. So you can actually go x plus 1 into x minus 1 all over x plus 1. And guess what? X plus 1 will handle that x plus 1, and you are left with an x minus 1. Remember, this is what k is. Now, to differentiate, to show that you are differentiating, you will go dk dx, because the name of the expression is k. Just as we have been going dy dx when the expression was called y, we do the same thing now because the expression is called k. And guess what? The derivative here will simply be a 1. That's how easy it is. All right. Now let's take it up a bit and show you how messy it can get. You can get to a point where you actually need to factorize and remember stuff like the sum of cubes, the difference of two squares, and that kind of a thing. So I don't know, how am I going to do this one with you guys? Okay, it's fine. Let's have a bit of fun. Let me give you a nice one. You're supposed to factorize, and this is when the examiner really wants to scare you. You're supposed to find the derivative of this. Two x plus 2. So watch again. I'm going to keep this as it is, but now I need this trinomial in a standard form. So I'm going to factor out the negative in the numerator. So as you note, each term then takes the opposite sign, and I will note that I actually have a common factor in the denominator. So I might as well factor out the 2. Take note, it's all going to stay in these square brackets. Never going to go away. Now I'm going to factorize x squared minus 3x minus 4. You got to see this. That's an x minus 4 into an x plus 1. And then I've got a 2 over x plus 1. And this is the point. You want to get rid of that, right? Because it is really making life difficult for you right now. So you're going to get rid of that. Now watch what I'm going to do. I'm going to multiply back the negative. So I have a negative x plus 4 all over 2. Now you know our little trick by now. I'm going to split that up. So this becomes negative x over 2 plus a 4 over 2, which is just a 2. And now, because I'm able to apply the law, I leave out the d dx. I stop writing out d dx. Then this becomes just minus a half, really. That's all it's going to become in this instance. All right. Guys, I wouldn't really mind taking questions. So if something becomes unclear in the process of me explaining, you can just raise your hand or put something up in the chat there. Okay, I've got one for you to try, and I hope you are ready for this. Let's go. So you're finding dx. And then I'm going to try and be kind. So x cubed minus 4x all over 2 minus x. Give it a try, guys. I'll give you about 3 minutes. 1, 2, 3. Yeah, which is more than enough time. Okay. All right, guys, we should be done. And remember, you're going to keep dx and deal with the fraction line here. And by now you know that factorization is probably your way out. So if we factor out the numerator, that will be x into x squared minus 4. And then you're going to have a 2 minus x there. I'm going to leave it as it is for now. And then we notice difference of 2 squares. Then we note that there must be something going on with the x minus 2 and the 2 minus x. So we do this thing called the change of sign, of simply put, you factorize a negative 1, then watch what happens. Bravo, the denominator is out. So what are you left with? You are left with a minus x squared minus 2x. I did skip a step there, but I'm sure you will notice what happened. So finally, your answer is a negative 2x minus a 2. So these are the long and short of it as far as complex problems are concerned. As I said, I do advise you to go and revise your methods of factorization. That's what is going to help you to see what kind of method you're supposed to apply when you factorize. So as you can see, we've done difference of 2 squares, highest common factor, trinomials, and guess what? I've not given you one on cubes, on the sum and difference of cubes, but watch out, I could give you one, okay? I'm just going to put it up here and you go try it yourself and see if you can come up with something if I give you x cubed minus 27 over x minus 3. And I know there is an inclination here again to cancel stuff out and say that, then x squared, that 9. That's very wrong. 0, I promise you that. Okay, so go look at your factorization. If you can do that, if you see that difference or sum of cubes, you're good to go. Okay, let's close it off by looking at the expressions which have letters, only letters. Now, there are no numbers, and I want you to note the difference. I hope you will really get to see it. I'm just going to give you one example here, and then I will give you some exercises to actually try out. So let's say we have y is equal to, let's just give you a cubic function here, ax cubed plus bx squared plus cx plus dy, cubic expression, more of that. So same thing, I'm going to write the same thing both sides. Ax cubed plus bx squared plus cx plus d. Now, I need you to be aware of the fact that asking you to find dy dx is really different from asking you to find dy d, let's say db. These are two different things. When I ask you to find dy dx, I am saying, yeah, look at the expression y, differentiate that with respect to x, which means you are treating every other letter as a constant, as if it was just a number. So when we apply our rule here, we will have 3ax squared plus 2bx plus ac. That's it. But on the right-hand side, watch what happens. Because I'm asking you here to differentiate with respect to b, really everything else is seen as a constant. And what do we know? As I said, now, this is where those little things which I say and do not write come into play. It means then everything else is a constant, and we must remember the derivative of a constant is 0. So this is becoming a 0, that's going to become a 0, that's going to become a 0. The only term that's going to be saved is that bx squared, okay? It's that bx squared term because it has a b. Not the stinging b, but it has a b, the letter b. Now, be careful again, because the temptation will be to write that as a 2bx. But you're not differentiating with respect to x. You are differentiating with respect to the letter b, which means you need to see x squared as a coefficient. So you need to see this term. You need to see this term here as x squared times b. So when you differentiate with respect to b, you're actually having an exponent which is 1. So 1 times x squared is just x squared, and 1 minus 1 is 0. So b to the power 0 is a 1. So actually you are left with just x squared. This is really important to understand, guys. And for this one, I'm going to ask you to do 2 problems for me, to sort out 2 problems, to, in other words, solve 2 of these, or, well, differentiate. Just so that I can be rest assured that you know what's going on here. Okay, so you're going to try these. Here's the first one. D dx, and what have we got here? Oh man, this is very interesting. A square root x plus 2mx squared plus k over x. So that's the first one that I would like you to try. The other one that I would like you to try is this. And you see I'm just writing out some funny or weird notation here, because I want you to get used to this notation. mk cubed minus n cubed k plus p squared. Right. Yeah, let's just try that. Let's just try that in the next 5 minutes. So I'll give you up to 5 minutes for both. So just a few things to note. For the one on the left, we need to sort out that square roots. So it's going to be 8 times x to the half. This one here is okay, no issues. But this one we must write as k times x to the negative 1. Okay, it's just what we've been doing. Remember, as I said, once they tell you d dx, treat every other letter as a number. Don't try even and look at it as something else. That'll complicate you, your understanding. All right. Now we differentiate because we have everything in our good form there. So this is half times a, and then x to the minus half. This will become 4mx, and this will become a negative k times x to the minus 2. So that's what you should get. You're probably looking at what? 5 marks, I suppose. Then here, we're good already. I mean, k is clearly visible. No square root signs or cube root signs around k. K is not in the denominator, so we get straight into it. This will become 3mk squared. So you just treat k as an x minus 3. No, that caught me. That should be just minus n cubed, because the exponent of k is 1. Now p squared, there's no k next to it. It means we treat it as a constant, and the derivative of the constant is a 0. So this one, nice and easy, 2 marks. So that will be about it. And all that's left for you is to actually practice and practice. But I want to do one more, and this is the one that I will close off with, which is a bit complex, okay? What makes it complex, again, is the fact that you kind of have to do some solving here. So I'm going to do 2 complex problems as I close off, okay? And this, I think this will be the ultimate. This is how worse it gets, all right? So don't stress. If you understand the next example, you should pretty much be okay. All right. So again, we want dy dx. Okay, so determine dy dx if the following is true. Watch. Number 1, if xy minus x cubed is equal to x squared. That's the first one. Number 2, if 3y minus xy is equal to x to the 4 minus a 9x squared. So remember, you cannot find dy dx unless you have y, the letter y, as a subject of the formula. So we need to make sure at this stage that we do actually, in each case, have the letter y as the subject of the formula. The one on the left is quite easy because then y becomes x squared plus x cubed. Then I divide by x, so to get x plus an x squared. So this one is quite easy to make y the subject of the formula. Now I can find dx, which becomes 1 plus 2x. But it's a bit of a problem on the right-hand side. And again, as I said, if factorization is your weakest area, you're going to battle a little bit here. You need to tune that up before your junior exam. So I'm going to factor out a y, then I have a 3 minus x. Watch that. Because y is a common factor on the left, and I want to make it as the subject. So then I'm going to divide by 3 minus x. So that's x to the 4 minus 9x squared over 3 minus x, right? Then if you notice, this problem now looks like one of these. So you now know it's a call for factorization. I'm going to factor out an x squared so that I'm left with an x squared minus 9. And this is a 3 minus x. And I notice I've got dots, the difference of two squares. So that's x plus 3, x minus 3. But guess what? I got to do a change of sign with that x, with that 3 minus x. So that actually x minus 3 can divide x minus 3. And then I'm left with, I'm just going to be quick here, minus x cubed minus 3x squared. This is what y is. So dy dx will become a negative 3x squared minus a 6x. So this I think this is the extreme case. So you should be able now to do all problems in that calculus section from your booklet, all questions on differentiation. You should keep practicing. Where it says first principles, do that. And where it says find the derivative or find ddx, whatever notation they use, there shouldn't be a problem that you struggle with, okay? You struggle, I'm a text away, always happy to help out. Okay, guys, please allow me to leave it here. We will then meet on Sunday to do some more calculus. On Sunday, I think we will be in a good position to start with some graphs, some graphing, and see actually how calculus has an application in our graphs. We're going to empower now, add to your toolbox of graphing or answering questions on graph. We're going to add that now methods of calculus to be able to do that. All right, I'll see you then. Stay tuned.